We're solving systems. We solve systems of inequalities. Now we're going to be solving systems of equations. What does systems mean? More than one. Okay. So we're going to be solving systems of equations. So no longer inequalities, just equations, meaning there's an equal sign with them. So a solution, if it's a graph, well, when it was an inequality, where was the answer for a system of inequalities? Where were you finding answers? Yes, ma'am.
They were both shaded.
Right. Double shaded. So the things that they have in common. So when it comes to a line or two equations, we're going to solve them by graphing today. There are three ways that we are going to solve systems. Today is graphing. Tomorrow and Monday will be another type, and then next week, at the end of the week, we'll have the third type. Today is going to be graphing. Where do we think answers are going to be when we solve a system by graphing? There's no shading when we have equal signs, right? The shading is now gone. Yes, ma'am. Where they cross. So, perfect. Wherever their intersection is, that is going to be our solutions. So we're graphing, finding where they cross, that's our solution. So let's go down to these bottom ones. So on number 1, is this first one in slope-intercept form ready to go?
Yes.
Okay, then let's graph it. Y-intercept's at -2. If the slope is 2, that means we're going to go up 2 over 1. And it's equation, so we just draw a regular line. There's no more shading because that's only for inequalities. Now for the second one. Is the second one ready to go for graphing? No. So put it into slope-intercept form first. What's the first step for that slope-intercept form? Subtract the 6x to move it over. So that means it's going to be -6x plus 18. Now what? Divide everything by 3. When we divide everything by 3, -2x plus 6. We good there?
Yeah.
Okay. Now we're ready to graph. Y-intercept is at 6. Slope's -2, so where are we going? Down 2 and right 1. Down 2, right 1, down 2, right 1. Woo! Where's the answer? Right there. Where they intersect. Yes. Okay. So let's move on to number 2. Number 2, that first one's ready to go. So slope-intercept form. I use different colors for these. If you like to use different colors, by all means, go for it. If you don't care, then who cares? So y-intercept is 8. Wrong spot. 8. And if the slope is 2, what direction are we going? Up 2 and right 1. That does not fit on the graph, so what's the opposite of going up and right? Down and left. Okay, is that second equation ready to go? Not yet. So what do we need to do to make it slope-intercept form? Add x, so that makes it a positive x on the other side, plus 6. So y-intercept is at 6. And if the slope, what's the slope of that one? 1, right? It's positive 1. That means up 1 and right 1. Or going down 1 and left 1. Oh, that's not a pretty straight line. Oh, we saw where the intersection was. Where's the intersection? -2, 4. How do we feel? Feel okay? If you're strong at graphing, you're gonna be fine with this, solving systems like that. It's just graphing 2 lines, see where they cross. So flipping over to the other side. I want y'all to do numbers 3 and 4. Ready, go. So let's talk about special cases. The first one's ready to go for graphing, so we can graph it at y-intercept of -2, then up 2 and over 1, or down 2 and left 1. So there's the first one. Graphing the second one, getting it in slope-intercept form, what would you have to do?
Subtract 2x. I mean, add 2x.
Add 2x. So y equals a positive 2x plus 4. What do you notice about these two lines? They are parallel. How do you know from the equation that they're parallel? Same slope. Okay. So they do not do what? They don't intersect. So they're parallel. They do not intersect or they don't cross. Whichever one you want to, whichever word, they're interchangeable. And if two lines are not going to cross or intersect, well, where have our solutions been? Yeah. Our solutions are the intersection point. Wherever they cross, that's our answer. If they're never going to cross, then what's our answer going to be? No solution. There is no solution. There's going to be no number or no point that they ever cross. Therefore, every time when it's equations, every time that you have a parallel line, set of lines, your answer will always be no solution. They have to be parallel to be no solution. Sometimes you'll have a graph where maybe you don't quite see the intersection point yet, but if they aren't parallel, they would intersect eventually. So you've got to kind of do some work for that one. But if you can see that they're parallel, then it's definitely no solution. So let's go to the other one. The other special situation. First one, ready to go, slope-intercept form. Y-intercept at -3. The slope is 3, so that means up 3 and over 1. Okay. The second equation, what would you have to do to get into slope-intercept form? Add 3. So that means it would be a positive 3x minus 3. What just happened? They are the same line. There's a vocab word for that, and that vocab word is called coinciding. Coinciding. Meaning you got two different equations, but in reality they're the same thing. They're right on top of each other. So when they are right on top of each other, where are they crossing? Everywhere, always. So what are the solutions? I'm hearing it. Infinite solutions. You can either write it as infinite or infinitely many. Those are interchangeable phrases for it. So anytime we have the same lines, that is called coinciding. So if you see that word, something about coinciding, that means that they're the same thing. Anytime you have coinciding lines, they have infinite solutions. All right. Ready for some more problems? Yeah. Okay. Word problems. We have 3 word problems and then we'll go home. So, Video Club A charges $10 for membership and $4 for movie rental. Video Club B charges $15 for membership and then $3 for movie rental. For how many movie rentals will the cost be the same at both video clubs? And what does that cost? That means you need to write an equation first. Let's talk about Club A. What's the equation for Video Club A going to be? 4x, wonderful, plus 10. It's $4 per movie plus that $10 membership. What about for Club B? 3x plus 15, 15 plus 3x, yes, those are interchangeable, so wonderful. So if we graph this, so if we start with Video Club A, y-intercept at 10, Does that graph fit nicely? Okay. Our answer is where they cross. We could get lucky and maybe they cross at like one of the exact numbers that we have on here. What could we do also? Instead of making it a graph, what's another way to show points other than graphing? A table. Can we make a table out of it? So, if we make a table, we have 0, 10. One movie would cost 14. 2 movies would be 18. 3 would be 22. 4 would be 26. 5 would be 30. I ran out of space, so maybe let's just add on if we need to. Okay, so we can kind of graph it and get the idea of it. It's going by 5, so graph it as nicely as we can. Now let's do Club B. So for Club B, 0.15, and then it's $3 for additional movies. So for one movie, we have 18, and then for 2 it would be 21. For 3 it would be 24. I don't know about y'all, but as I'm writing these points down, I'm looking back at the other table to see if there's ever going to be something matching. Because if we get something matching, then we can start making the table. 4 would be 27, nothing matching so far. Oh, 530. Woohoo. So we can see our answers visually in a table as well. Whatever point they both have, that's our answer. But we're also asked to graph it, so we have to graph the thing that's going to match with it. So 515, or 0.15, geez. 118, 221, 324, 427, 530. Just do as best you can. That's why you wrote the table off to the side. Okay, so let's go down to the next one. On the next one, Ren and Jenny are reading the same book. Ren is on page 12 and reads 3 pages. Oh, wait, back up to the other one. My bad. We didn't answer it. Yes, we got an answer, but we didn't, write it out. We know the answer is 530. It's a word problem. What would the answer be? 5 movies cost how much? So both charge $30 for 5 movies. Okay. Now let's go back to Ren and Jenny. So Ren and Jenny are reading the same book. Ren's on page 12 and reads 3 pages every night. Jenny's on page 7 and reads 4 pages every night. After how many nights will they have read the same number of pages, and how many pages will that be? So we have 2 girls, or people, yes. We have Ren, and then Jen. They're reading at different rates, different amounts. How would we write an equation for Ren's reading? Three a night, so 3x plus 12, because that's where she's starting from. And then what about for Jenny? 4x plus 7. Okay. Before we make the graph, One's starting at 7, one's starting at 12, one's going by 3, one's going by 4. The chances of us having exact intervals for our x and our y, slim to none. Just because those numbers are not very nice with each other. So let's do the same that we did before. Make a table first, then we can kind of make the graph that goes with it. So if we're making that table for rent, 0, 12, 1, 2, 3, 4, let's try 5 again, maybe we can stop at 5. So 12 books to start, then what? 15, 18, 21, 24, 27, maybe let's do 6, 30. Just make it end on a nice number. Okay, let's do Jenny's. Now again, as we're writing out Jenny's, kind of look back at Ren's and see, like, did we find something that's matching? Because then we can stop. So 0, 1, 2, 3, 4, 5, 6. So we have 7. What would be next? 11, 15, 19, 23. I'm not seeing any matching so far. 27.
That's matching.
Oh, we got a match. What does that match mean? What does that 5 and 27 represent? Yeah. On day 5, they both read 27 pages. Okay. And because there's a blank graph, we need to graph it. The x values, we have the same x values. We can count by ones on the x-axis. And x would be what? What would we label that axis as? Days, okay? And then the y-axis. What kind of goes good with both of them? Ish. Going by two, that wouldn't be terrible. I think there's another option that might be a little bit better. 1 isn't gonna fit, right? I think 3s is kind of nice. Do y'all know why I'm thinking 3s is nice? Number 1, it matches with our answer. 27 is a multiple of 3. But also look at Ren's. All of Ren's y values are multiples of 3s. So it fits nicely. And then some of the Jenny ones are multiples of 3s. So if we make it going by 3s, kind of helpful. It makes it a little bit easier for graphing. As long as our answer will fit on there, we already know the answer. So as long as that fits, oh, and it will, then we're good. And y value was pages. So graphing Ren's. Look how easy Ren's was. Jenny's a little bit more work. So 0, 7, 1, 11, 2, 15, 3, 19, 4, 23, and then 5, 27.